This channel is mainly about murder mysteries, where there's a problem, who done it, and a question to be solved. So, in order to answer the question, we do investigations, do we not? But if the question is, what is the ultimate nature of reality? Then we move into the realm of physics. Same thing. Asking a question. Who did it? How they did it? When did they do it? Why they did it? Well, in the case of nature, it had to be. But what is that reality in itself? In other words, where's the body? Is there a body? In order to get there, we're going to begin with something simple. We're going to begin with a physics question you already know the answer to. Dialogue concerning the two chief world systems by none other than Galileo. No, the Inquisition did not see the humor. Okay, what this is, the two chief world systems, is a difference between Ptolemaic, Earth in the center, and being of necessity flat, thus totally ignoring gravity, or Copernican, in which gravity rules. Now, unfortunately for us, I recommend you read that book, by the way, Galileo's. Very entertaining. But it also does one other thing. It introduces you to the concept of a thought experiment. Yes, even the ancient Greeks knew the earth was round. Measured time, measured distance. They had astrolabes and the Antikythera mechanism. So, yeah, they had their science. And yes, they knew hail and snow were made out of water. Yeah, they did. They even knew atoms existed, so let's cut the crap, okay? However, after you read the Galileo's book, this one. Now, Professor Anthony Z got his doctorate from Harvard, but don't let that bother you. This is a physicist, a theoretical physicist. Fearful Symmetry. It's all about physics. And his premise is that gauge symmetry is the way forward, and group theory. Now, this book was written in early 2000, so naturally it's a little old. But you'll find this a bit of a mind stretch, especially the part about group theory. You have to get used to mathematics not being quite what you thought it was. And he introduces you to the wonderful world of the quantum. Of course, now we have quantum chromodynamics, but you know, time marches on. Talking about things like covariance and how can probability become 0 to 1/3, and you can't tell because you don't know, because of the uncertainty principle, and so on and so forth. And on we go into the future. But go you must. That's why this is a mind stretch for most people. In fact, that was the first science book I ever read. Back when I was a teenager. So this is kind of like a return to my misbegotten youth, no doubt. However, I recommend that you delve into it, because the Higgs boson was found. Unfortunately, it decided it was going to play right across the middle. Neither a superstring nor a supersymmetry. You're kind of just two competing theories about the ultimate nature of matter itself. And there's a gap in between the two, and that's where nature went. It was lovely. Yeah, kind of leaning one way, but not enough to really be definitive. So there's something we don't quite understand yet. So it's interesting to see where we'll go next. Will we find out the ultimate nature of the universe and matter and reality itself? Perhaps. We'll see. This is one ongoing mystery that as yet remains to be solved. So, don't be afraid of physics. Don't have to do the math. You just have to understand the concepts. Because it's the intellectual concepts that lead you down the path. For further exploration of this topic, you really should watch The Particle. What is that called? There's a movie available that tells you all about it. And I will post a link down below as soon as I gin up my YouTube and find out, because I bought it. It's a great movie. You should watch it. You really should watch it. It's excellent. Anyway, thank you for watching, and please do come again and grab this book after you read the Galilean book. You need a little exercise here. Besides, take your mind off of what's going on, won't it? Give you a bit of a rest. Thank you for watching, and please do come again.